Why should you maintenance steam traps? Many sites have hundreds, if not thousands, of steam traps, and one malfunctioning steam trap can cost thousands of dollars in wasted steam and energy per year. Two of the most common causes of trap failure are oversizing and dirt or corrosion. Oversizing causes traps to work too hard. Rapid cycling, things such as that. Dirt is always being created in a steam system. Excessive buildup can cause plugging or prevent the valve from closing. Dirt is generally produced from pipe scale or other overtreating of chemicals in a boiler. There are basically three common methods of checking steam traps. The first would be visual observation. You know the difference between flash condensate and live steam. In a closed return system, a test valve should be installed downstream. The second common method would be ultrasonic or sound. You must have a listening device to hear the action of the trap. You're going to have to know how these certain traps operate. The third style would be temperature measurement. This would be done with an infrared gun. You must have a temperature sensing device to measure the temperature differential on the inlet and outlet of the trap. There are common characteristics of several of the steam traps that are out there. A mechanical trap or an inverted bucket trap. These types of steam traps have a bucket. This bucket rises or falls as steam and or condensate enters the trap body. When steam is in the body, the bucket rises, closing a valve. In other words, the inverted bucket, the trap valve is at the top of the body. As condensate enters, the bucket sinks down, opening a valve and allowing the condensate to drain. Inverted bucket traps are ideally suited for water hammer or rigorous conditions, but may be subject to freezing in low temperature climates if not insulated. Usually, when this trap fails in an open position, either the bucket loses its prime and sinks, or impurities in the system may prevent the valve from closing completely. These are very common for airlock, and they should usually be used in a main drip or tracer application, but not necessarily in a process with varying loads and varying conditions. Characteristics of the steam trap failure. Here is a thermostatic or bimetallic or bellows steam trap, as they're called. These steam traps have as the main operating element a mechanical corrugated bellows that is filled with an alcohol mixture with a boiling point lower than that of water. The bellows will contract when the contact with condensate and expand when the steam is present. Picture your thermostat on the wall, very much the same condition. Should a heavy condensate load occur, such as in startup, the bellows will remain in a contracted state, allowing condensate to flow. As steam builds up, the bellows will close. Therefore, there will be a moment when this trap acts as a continuous flow type. This style of trap has, if you're working with it in a steam system, will cause a lot of subcooling. It's relatively slow to react, so you'd want to put it in more of an HVAC style application and not necessarily in a condition where backing up condensate in your system can cause any sort of problems. The bimetallic is not a filled device. The bimetallic is a metal device that will contract and expand dependent upon the ability or the manufacturer of the steel to do that. This will cause you can handle very heavy loads, very high temperatures, very rigorous conditions, but again, it's a very slow acting device. This is probably one of the most commonly used traps, and I will say probably one of the most misapplied steam traps. Thermodynamic steam traps, they have discs that rise and fall dependent upon the variation in pressure between steam and condensate. Steam will tend to keep the disc down or in a closed position, commonly called flash as well. As condensate builds up, it reduces the pressure in the upper chamber, allows the disc to move up for condensate discharge. This trap is a good general type trap where steam pressures remain constant. It can handle superheat and or water hammer, but it's not recommended for processes since it has a tendency to air bind and does not handle pressure fluctuations well. A thermodynamic trap usually fails in the open position. There are other conditions that may indicate steam wastage, such as motor boating or rapid cycling, in which the disc begins to wear and fluctuates rapidly, allowing the steam to leak through. This trap is generally a relatively inexpensive trap. You'll find it on main headers. You'll find it on constant pressures. You'll find it in a lot of the tracing systems that are out there. It is not to be applied on a process system because the air locking will cause that trap to fail in a closed position in most cases and will back up condensate into your process system. It can be a common water hammer issue. A floating thermostatic style trap. This would be what I would consider a process steam trap. Floating thermostatic traps consist of a ball float and a thermostatic bellows element. As condensate enters through the body, the float rises or falls. Open your valve according to the flow rate. The thermostatic element discharges air from the steam lines. They are good in heavy and light loads and on high and low pressures. They're not recommended where water hammer is a possibility. There is a float in there, you will damage it. It is a mechanism, a mechanical mechanism. When these traps fail, they usually fail closed. The reason they would usually fail closed is the seat on this trap or valve, if you want to call it that, is at the bottom, so any corrosion or dirt will build up in that seated area, not allowing for it to close off completely. The ball float may be damaged and could sink also. Water hammering can cause that. This would cause you to fail in an open position. The thermostatic element may also fail and cause a fail open condition. This is a two-valve trap, basically. You have a valve for discharging the air until you get up to the saturated condition, and it closes off. And you also have the float, so you can discharge large condensate loads, but also filling the cavity and allowing it to float and operate in a modulating condition. This is an orifice trap. In the case of a fixed orifice trap, these generally are traps that have a single drilled orifice in the unit. They have a tendency to waterlog under high loads because it is an orifice, it is a valve. They're working under a condition that it's assuming that you have a pressure and temperature that is very consistent and is sized for that. It is basically an orifice in the line or a hole drilled into the line that will allow you to use it. They're very rigorous. They hold up in multitudes of conditions, which should only be applied in a main steam line where you have a constant pressure temperature situation. What are the indications of a possible steam trap failure? Abnormally warm boiler room. Generally, this would be because you've got steam flying through the system, back into your condensate return tank, and you're discharging a lot of flash through your vent line. Condensate received through the venting system. This is your deaerator or condensate return tank receiving higher temperature than it should. Condensate pump water seal failing prematurely. This generally would indicate that your condensate pump, which is an electronic pump, is pumping at temperatures too high for the unit, would cause cavitation. Overheating or underheating in conditioned space. Same situation. You have too much heat or not enough heat out into your HVAC area. Your boiler operating pressure, difficult to maintain. You're having all kinds of fluctuations in your header. Vacuum in the return lines are difficult to maintain. In a low pressure system, you would have a vacuum return pump, and live blow-by steam can cause for the failure of that vacuum. Water hammer and steam or condensate lines. If a trap is blowing live steam through and you're returning all your condensate, that live steam enters into your condensate return line that is generally full of water and only flash. Steam in the condensate return lines, which we just addressed. Higher than normal energy bill. Obviously, if you're leaking steam and you're losing condensate, you're paying much higher bills for bringing in city makeup water, treating it with chemicals, and the added amount of energy through gas or oil to heat it to its saturated area. Inlet and outlet lines to trap nearly the same temperature. This is where you would use an infrared gun to check your inlet and outlet of your steam trap to see if there's a differential in temperature. It can indicate either a blow-by trap or it could indicate a clogged trap, depending upon which style of trap you're testing.